Hey everyone! Today we're diving into the fascinating world of virtual memory. You know how your computer seems to juggle a million things at once, running apps, playing games, and streaming videos without breaking a sweat? Well, virtual memory plays a huge role in making that happen. Think of your computer's memory like a physical desktop. You've got limited space, right? Now imagine you've got a ton of papers you need to work with. Way more than you can fit on the desk at once. That's where virtual memory swoops in to save the day. Instead of cramming everything onto your limited physical desktop, virtual memory acts like a much larger virtual desk. It lets your computer access and use more memory than it physically has by cleverly swapping data between RAM and your hard drive. This allows your computer to run programs and processes that require more memory than is physically available. Pretty cool, right? So what exactly is virtual memory? In a nutshell, it's a memory management technique that creates the illusion of having more RAM than you actually do. It's like magic, but instead of pulling a rabbit out of a hat, your computer is pulling data from your hard drive and loading it into RAM when it's needed. This trickery is possible because virtual memory treats your hard drive as an extension of RAM. When your RAM is full, virtual memory steps in and moves some of the less frequently used data from RAM to a designated area on your hard drive called the page file or swap space. This frees up space in RAM for your computer to keep running smoothly. Now you might be thinking, but Linus, isn't my hard drive much slower than RAM? You're absolutely right. Accessing data on your hard drive is significantly slower than accessing it in RAM. But virtual memory algorithms are designed to minimize this performance hit by cleverly predicting which data you're most likely to need next and keeping it in RAM. One of the key mechanisms that makes virtual memory possible is called paging. Imagine dividing your computer's memory into small, equally sized chunks called pages. Now imagine dividing your hard drive swap space into the same size chunks, which we'll call page frames. When a program needs to access data, the operating system first checks if that data is already in a RAM page. If it is, great. If not, the operating system locates the corresponding page frame on the hard drive and swaps it into an available RAM page. This process is called a page fault. Paging allows your computer to load only the necessary portions of a program or data into RAM at any given time, making much more efficient use of your limited physical memory. It's like having a giant library and only checking out the books you need instead of hauling the entire library around with you. Section 4 Advantages: Why virtual memory matters. So, why is virtual memory such a big deal? Well, for starters, it allows you to run programs and applications that require more memory than your computer physically has installed. This is especially important in today's world of memory-hungry software and multitasking madness. Virtual memory also makes multitasking much smoother. With virtual memory, each program gets its own virtual address space so they don't step on each other's toes. This prevents conflicts and crashes, keeping your computer running smoothly, even when you're juggling a dozen tasks at once. Another benefit of virtual memory is increased security. By isolating each program's memory space, virtual memory prevents malicious programs from accessing data they shouldn't be able to. It's like giving each program its own secure vault to store its data. Section 5 Disadvantages: There's no such thing as a free lunch. While virtual memory is undeniably awesome, it's not without its drawbacks. As we mentioned earlier, accessing data on your hard drive is significantly slower than accessing it in RAM. When virtual memory has to swap data between RAM and your hard drive too frequently, it can lead to a noticeable performance hit, making your computer feel sluggish. This is often referred to as thrashing. Another potential downside is complexity. Virtual memory management adds another layer of complexity to your operating system, which can make it more difficult to troubleshoot memory-related issues. It's like trying to solve a Rubik's Cube while riding a unicycle. It's doable, but it requires some serious skill and patience. Finally, virtual memory doesn't magically create more RAM out of thin air. It's simply a clever way to utilize your hard drive as a temporary extension of RAM. If you consistently run programs that demand more memory than your computer can handle, you'll inevitably run into performance issues, no matter how much virtual memory you have configured. Section 6 Virtual Memory in Action: Powering Your Digital World. So there you have it, virtual memory in a nutshell. It's a fundamental concept in modern computing, allowing our computers to do more with less. From running memory-intensive applications to enabling seamless multitasking, virtual memory is the unsung hero behind the scenes, working tirelessly to keep our digital lives running smoothly. Next time you're browsing the web, editing a video, or just casually chatting with friends online, take a moment to appreciate the magic of virtual memory. It might be invisible to the naked eye, but its impact on our digital lives is undeniable.